Start.
Now, in this session, we are going to discuss about the hypergeometric distribution. See, the significance of the hypergeometric distribution before going for to get that idea of the hypergeometric distribution, we recall that binomial distribution. In that binomial distribution, in the earlier session, we discussed that 0, 1. That 0 is failure, 1 is the success. Here, in the binomial distribution, the same analogy we are using, but with replacement and without replacement. See, without replacement, suppose 6 balls, from the 3 balls, we have to choose the 2 balls in each. There is 3 possibilities. But if without replacement, 3 to the power of 2. Okay, so this is the permutation and the combination. So without replacement is power, with replacement it will be reduced. Based on that, we are defining the hypergeometric distribution. Then as a continuation, hypergeometric distribution tends to be the binomial distribution. You studied in your UG class that binomial distribution tends to Poisson distribution provided the condition P tends to infinity. There is very least success. Then another condition NP tends to infinity. Then another proof that we proved that binomial distribution tends towards the normal distribution. These are all studied in your UG class. Now we are going to discuss about this. Also you studied in your UG class that hypergeometric distribution tends to the binomial distribution. Here only also we are going to two conditions. See, first we have defined the hypergeometric distribution. A discrete random variable is said to be hypergeometric distribution if it assumes only non-negative values. So it's only the positive values, and its probability mass function is given by probability of x equal to k success RCK NCR by NCM. So this is the all possible, this is the favorable, then combination of n minus k. If you then take that 0, 1, 2, this is a discrete values. This is the hypergeometric distribution. Otherwise 0. Okay. Where n is the number of balls in an hand, r is the number of white balls, and n minus r drawn without replacement. So only one condition is that r is the number of white balls, then remaining are whatever may be the color, but drawn without replacement, and k is number of white out of n. So the white balls you are choosing n minus r drawn, then k is number of white out of n. So this is the NCN. So among these white you have to choose the r balls. So this is the condition for the hypergeometric. Prove that hypergeometric distribution tends to binomial distribution as n tends to infinity. That is number of trials is infinite. Prove the hypergeometric distribution is given by we already defined this the definition. Then we have the condition while the condition n tends to infinity, probability of sk you have to expand NCR equal to n factorial divided by r factorial into r minus n minus r factorial. We are expanding. After that, you have to substitute that n tends to infinity. If you have simplified, you are getting the value of that. This is the limit n tends to infinity. N factorial, k factorial, n minus k factorial. This is the number of success, remaining is the number of the failure. This is more or less close to the binomial distribution. Then we are substituting in the place of the n minus r. This is one condition you have to recall. This is the total number of taken. This is the number of n is the total number of balls. The second proportionality success. Therefore, p the number of success equal to p equal to r by n. We are replacing that. Then we are getting that as n tends to infinity and 1 minus n is the average value of the taken as a boxes. So it will be reduced that the k times success n minus k times failure, that is reduced as the binomial distribution. NCK p to the power of k 1 minus p to the power of n minus k. This is the binomial distribution. So this is in the case of the hypergeometric distribution that one first condition is n tends to infinity, then np equal to r, therefore p probability of success equal to r by n. While you are introducing the hypergeometric distribution